So what do we do with I? So the two things we learned, I is the square root of -1, right? The complex, its imaginary unit. And then what is I squared? -1, because you just square both sides of that, you just tear off the root, huh? So I squared is -1. So whenever we see I squared, so that's a funny we never leave I squared. We always replace I squared with -1, huh? We never leave I squared. We always replace it with -1. Whereas regular I, we just leave. But I squared, we always replace with -1. Okay, that I think. Okay, so what do we do with 6 over 4 minus I? How do we handle it? What do we do? That really means that I in the denominator down there, that really means square root of -1. So that really means a square root in the denominator, doesn't it? And remember how we never leave square roots in the denominator? So that's really the issue that's going on here. When you see an I in a denominator, you should think, oh, that's a square root. And we don't leave square roots in the denominator. So, like what if we had, 4 minus square root of 3 or something? It's the same kind of thing. What would we do about that? What do you multiply by to get rid of that? Can you just multiply by like root 3 over root 3? Would that take care of it? No, because of the plus or minus. Now, if that wasn't there, if it was just 4 times root 3, then yeah, root 3 over root 3 would be perfect. That would do it. Remember that from algebra? If you just have it times, no big deal. Remember, plus and minuses glue things together. Remember how I'm always saying that? That's a real important principle. So because of the minus, or plus would be the same deal, those are stuck together. Costco, I always call it, package deal. You got to buy the whole thing. Right? You can't separate them. So because that's the case, those are glued together, you would have to multiply by the entire thing, but opposite sign in the middle. It would be 4 plus root 3 over 4 plus root 3, but it's not really root 3. Let me go back to what it really is. It's I, so it's 4 plus I over 4 plus I. Do you remember that from your algebra days? That's called the conjugate. I'm not going to quiz you on the name. Conjugate just means opposite sign in the middle. And so whenever you have a plus or minus, so it's when you have an I with plus or minus in the denom, you do the conjugate thing. All right, so then you just multiply out that top there. What are we going to get? That 6 goes boom, boom. 6 times 4 is 24. 6 times I is 6I. Good there. And then we FOIL the bottom. Here we go. The 4 is going to go to both. 16 plus 4I, boom, boom, minus 4I minus I squared. Just kind of foiled that there. These guys cancel. That's perfect. That's why, you see, that's why we use the opposite sign, because that's what makes it always cancel. One of each, 1 plus 1 minus. That's why that works. Okay, so what do we got left? Well, the bottom, what do you always do with this I squared? That's -1, so that'll become minus 1, right? Instead of minus I squared, it's minus 1, which is plus 1. So this is 16 plus 1. This is 17. So 24 plus 6I over 17. That's a fine answer on the test. It'll probably look that way. Math Excel is super picky. Remember, they want you to separate it. So they want you to say 24 over 17 plus 6 over 17I. They want you to separate it into 2. That's what they're saying here. Form A plus BI. They want it separated. They don't want one fraction. They want 2 separate. There we go. Is that good? What did we do? What did we accomplish? We got rid of the I from the denominator. Now it's up in the numerator. That's really it. We don't want roots, don't want I's in the denominator. We brought it up top by that action. Questions on that one? Multiply by the conjugate? All right. So again, if this had been 6 over 4I, no plus or minus, what would I have multiplied top and bottom by? Just the I. That's the whole point, is they're not glued together. It's not Costco. It's just shopping at Save Mart. You can buy just one, right? They're not glued together when there's no plus or minus. All you need is the I. Does that make sense? Everybody seeing that difference? But with the 4 plus or minus, they're glued together, package deal. Got to have the whole thing. Pluses and minuses do that throughout algebra, which is, that's what pre-calc will be, and calc, it'll be advanced algebra. You'll have these rules all the time. All right, so we have 6i over 3 minus 8. You want to give that one a try? Give you a second. So clean that one up. So it's conjugate. You got the glue on the bottom, the plus or minus. So multiply top and bottom by the opposite sign in the middle. So we're going to multiply by 3 plus 8i over 3 plus 8i, right? Top and bottom, like that. Opposite sign in the middle. Because it's glued together, got to use the whole thing. Can't just do the I. Got to do the whole thing. Plus or minus is glue them together. Distribute. 18i. Plus 48i squared, boom, boom. 9 plus 24i, minus 24i, minus 64i squared. We good to there, and these cancel. And so then we get 18i. Now what are you going to do with 48i squared?
Switch the sign.
Yeah, that's a negative 1, huh? So that's going to become minus 48. Same thing down here. That guy's a negative 1, so it'll become plus 64. So we get 18i minus 48 over whatever, 73. So that wants you to separate them. In fact, you know what does it carry on the order? I don't know, probably not. 18i over 73 minus 48 over 73. There we go. We good? Get rid of the I from the bottom. I'll move on if you're okay. Any questions? Let's see. Wednesday's topic. So square root of negative 25 minus square root of negative 16. So what do you do with a negative inside of a root? Remember, because it's imaginary, huh? There's no number times itself that's negative 25, huh? You can't really take the square root of a negative number. So what do? You kick out that negative sign, and that makes an I, doesn't it? Same thing here. Kick out that negative sign, that makes an I. So we get I square root 25 minus I, square root of 16, huh? Everybody with me on that? Negatives inside of a root, so let me write that. Negative inside of a root moves outside, becomes I. So that's what you do when you have a negative in a root. Basically, it's imaginary. We're saying negative in root, that's not real. It's imaginary. You can't take the square root of negative 25. What times itself is negative 25? Nothing. Negative 5 times negative 5 is not negative 25. So there's nothing. That's why we say, well, it's imaginary. So we move out an I, and then as soon as we do that, we go, oh, well, then this is 5i, because square root of 25. Now that we got the negative out, we can do the square root, huh? We can do the square root of 25. And now that we got the negative out of the 16, we can say, well, then you're just 4i, because we can do the square root of the 16 now that the negative's out. And then 5i minus 4i is 1i, or just I. There we go. Good. Questions? Okay, so we've got negative 4 plus square root of negative 16 squared. So squared means you got to write two of them. But first, I would take this negative right here and put him out as an I, because that's what we always do with negatives inside of a square root. It's imaginary. Then I would go, well, that's negative 4 plus 4i. And write two of them, because squared means, square on a parenthesis means two of those parentheses, right? Is that too fast? Is that good? So the square root of the 16 is just 4. The negative inside means I. And then I would just FOIL it. Boom, boom. I don't know what that'll become. It's at positive 16 minus 16i, boom, boom, minus 16i plus 16i squared, 16 minus 32i, and this guy, because he's negative 1, becomes negative 16. 16 minus 16 cancels, minus 32i. We good? No questions? On we go. So on this one, the question is negative 12 plus, now the square root of negative 45, what am I going to do with that? Grab that negative, put it out as an I. So I root 45 over 24. So far so good. Negatives in a root, just kick them out as imaginary. They're imaginary. Okay, now the square root of 45, that needs to be simplified before I can go further. So the square root of 40, use your calculator. Some of your calculators will do the whole thing automatically. So break it down. 45 is 5 times 9, 9 is 3 times 3. Remember how square roots work? It's a 2-for-1 deal at Target. Shopping at Target this Christmas, 2-for-1 sale. 2 3s in, 1 3 out, and they're gone. So this becomes 3 root 5, doesn't it? The 5 has to stay in, because there weren't 2 of them. But the 2 3s go away and send 1 out. Remember, that's the Target deal. You buy 2, you go out of the store paying for 1. That's what square roots do. That's why they're called square roots. That means 2, right? This is called x squared, right? Square means 2. Cube means 3, for example, right? So this is called a square root because it's a 2-for-1 deal. That's what it is. So it's 3 root 5. Okay, so we get minus 12 plus 3 root 5. Oh, I forgot the I. The I is there too. Over 24, we good to there? Simplified that root 45. Now, we need to separate those and reduce both those fractions. So in other words, we get minus 12 24ths. A little scribbly there. Plus I 3 root 5 over 24. Good so far. And now 12 goes into 24 2 times. This is minus a half. Plus 3 goes into 24 8 times. I root 5 over 8. There we go. Just separated them and reduced them. All is well? Questions? All right, no question. All right, so we have square root of negative 27, square root of negative 5 minus the root of 2. Want to give that one a try? So the negatives in the roots kick out an I right away, don't they? So right away, send out an I. This negative comes out as I. This negative comes out as I. You got to simplify. The square root of 27 needs to be simplified, doesn't it? Break down that 27. You know what? 3 times 9, 3 times 3, right? Break down that root 27. Simplify that thing. Two 3's in, 1 3 out, the other 3 stays in. Is that good? 2-for-1 deal. 2 3's in, 1 3 out, the other 3 stays in. 3 root 3. So root 27 is 3 root 3. So this is I 3 root 3. This is I root 5 minus root 2. Now go ahead and distribute. Once you got them independently simplified, now you can distribute this times this and this. All right? You can finish that up. I times I is I squared. This is 3 root 15. Everybody okay with that? Right, the inside stuff multiplies the inside stuff, right? The 3 and the 5 multiply because they're both insiders. Remember the rules on all that? Insiders with insiders. Minus, and this is I 3 root 6. The insider 3 and the insider 2 multiply to be 6 there. That's the rules for roots. Insiders with insiders, outsiders with outsiders. Like that. Good. Now, what does that I squared do? What do we always do with I squared right here? Right here? Negative 1. So that just changes this to be negative 3 root 15. Right? It becomes negative. And there we go. There's our answer. Good? I'll do a couple of those hard ones and we'll take our test. Okay, so let's start by foiling these two. Boom, boom. 6 minus 2i, boom, boom. Minus 9i plus 3i squared. Is that good so far? Bless you. And then this minus sign in the middle here goes there, and then you got to FOIL that other stuff out. So I'll FOIL the other stuff. Boom, boom. 16 plus 4i minus 4i minus I squared. But notice how I kept the parentheses. Why did I do that? Because I'm worried about this minus sign. Remember, he's going to need to distribute to everybody. Everybody that comes after a minus sign, all the signs need to be changed. That's a really common mistake. Very easy to make. And as you go to pre-calc and then calc especially, if you're going that way, you really want to get that down because it'll keep coming up and up and up. It's those kind of things that make people not pass calculus. Their algebra skills are just a little too unperfected. So, make sure you're good with that kind of thing. And then these cancel. 16 minus I squared. I'll keep this here. So what do we got? 6 minus this, 11i, and this is going to become minus 3, right? Because that I squared becomes negative 1. Just changes the sign of whomever it's with. And then this minus sign distributes, minus 16 plus I squared. And then just gather, now this also is negative 1, isn't it? I could have just changed that earlier, huh? Whatever. Might have been easier, huh? Is that what, Wendy, you were thinking that. You were thinking, what is Mr. Heron doing?
He's not following the
Yeah. Okay, minus I squared. I should just make that plus 1. That'd be quicker, huh? Good? Minus I squared is actually plus 1 because I squared is itself negative 1. So negative 1 is plus 1. And this is just a 17. Yeah, that'll be nice. Just make it 17. There we go. So then 6 minus 3 minus 17 was that? Minus 20, minus 14. Minus 11i, I think. Yeah. No. Is that right? Yeah, that's right. Having trouble with those numbers. Use your calculator if you're not sure. There we go. Good. Just be careful with all those little signs and parentheses and everything. Is circuit stuff. Okay, there's a lot of words up there. Complex numbers are used in electronics to describe the current in an electric circuit. Ohm's law relates the current in a circuit I in amperes. The voltage of the circuit E in volts and the resistance of the circuit R in ohms by the formula E equals IR. Find E, the voltage in the circuit, if I equals 7 minus 3 I amperes and R equals that ohms, blah, blah, blah. So really, you don't need all those words. You just need this right here. E equals IR. And they're telling you I is 7 minus 3I. and R right here is 5 plus 6i. You with me? That's all you really need. They're saying find E. Well, what is E? It's I times R. It's I times R. It's 7 minus 3i times R. 5 plus 6i. So that's a bunch of fancy talk to say, hey, please multiply these two complex numbers. That's what they're basically saying, right? So that is circuitry. I don't know if anybody's going towards engineering. I was engineering before I changed my mind to math. I transferred to Cal Poly in computer engineering. I said junior college, I just took every math science class I could take because I didn't know what particular math science thing. So I took all the physics, all the chemistry, all the calculus, all the computer science, and all the engineering that my junior college had. And then I transferred to Cal Poly as computer engineering, did 1 year of that and thought, nah, I'm no good with my hands. It was too practical for me. I was in a class, a junior level class, and they just threw a breadboard, it's called. Maybe some of you know. I'd never heard that term before, which means a board that you wire things up on. I just went in a lab, and they said, all right, and you guys wire up this breadboard, and like everybody else was just going. Like, I guess they'd done this when they'd grown up fooling around with circuitry, I guess. Not me. I was just good with the numbers. I wasn't hands-on. These hands don't do nothing but write numbers. That's all they do. So I had all kinds of trouble that semester, and I changed my major to math. But anyway, I did a few of these before I switched out. So this about junior level. If you head towards any kind of engineering, so maybe a couple years away for you if you're going that way, junior level, I actually did some of these kind of problems. They're not that far away. All right, so you would just distribute 35 plus 42i, boom, boom, minus 15i, minus 18 squared, I squared. So then that's what, 35. This makes something, I don't know, 27, thank you. 27i. And this minus 8i squared again is negative 1, so that's plus 18, isn't it? And so then 35 and 18, 55, 53. 53 plus 27i, that would be the answer, the voltage in the circuit. We good there? Does that make sense? I always remember at Cal Poly, I took this one of my last circuitry classes at Cal Poly. The circuitry professor, he would be up there. There was no tests in this class. He would just give us a quiz like every week. And he never gave us enough time to do the quiz. Like he would always talk, lecture, like I'm doing right now, wasting all your testing time. He would talk, and we knew this quiz was coming at the end. And I would just sit there saying, oh, stop talking, give us the quiz. We don't have enough time. And I'd be watching the clock. Then he'd wait until there was like 15 minutes left. Then he'd pass out a quiz. He had like 5 circuit problems to solve real quick. He'd just go as fast as you can. And he'd go, time's up. Turn those in. It was just pressureful, I remember. All right. So there's the university.